Ray tracing has been the most talked about and most debated visual technology in PC gaming for the past several years, and the conversation has always circled around the same tension. The results look incredible when they work well, but the performance cost has been brutal. The visual artifacts from imperfect denoising have been a persistent source of frustration, and the gap between what ray tracing looks like in a perfectly optimized demo and what it looks like in an actual game running at playable frame rates has always been wider than Nvidia would like to admit. DLSS Ray Reconstruction was Nvidia's first serious attempt to fix the denoising problem at its root by replacing the hand-tuned denoisers that game developers were using with an AI-powered neural rendering model that could intelligently reconstruct the missing pixel data that sparse ray tracing leaves behind. It was a meaningful improvement when it launched. But Nvidia just announced at Computex 2026 that DLSS 4.5 Ray Reconstruction is arriving in August, and the improvements in this version are significant enough to genuinely change what ray-traced gaming looks like for everyone with an RTX GPU. Before diving into what DLSS 4.5 Ray Reconstruction actually does differently, it is worth understanding the fundamental technical problem that any ray tracing denoiser is trying to solve, because it explains why this technology matters as much as it does. When a game engine renders a ray-traced scene, the GPU cannot afford to trace a ray for every single pixel on the screen. Modern games use what is called sparse sampling, where rays are traced for only a fraction of the pixels in each frame and the results from those sampled rays are used to infer what the unsampled pixels should look like. The mathematical process of taking those noisy, incomplete samples and turning them into a clean, stable, detailed image is called denoising, and it is one of the hardest problems in real-time graphics rendering. Traditional hand-tuned denoisers that game developers write manually are effective but imperfect. They struggle with fine reflective surfaces, they can introduce ghosting and temporal instability in fast-moving scenes. And they sometimes smear or lose detail in complex lighting situations. DLSS Ray Reconstruction replaces these hand-tuned denoisers entirely with a neural network that has been trained on enormous amounts of ray-traced image data and has learned to make much more intelligent decisions about how to fill in the missing information. DLSS 4.5 Ray Reconstruction specifically upgrades the neural network at the core of the technology to a second-generation transformer architecture, and the improvements in this new model are measurable and meaningful according to Nvidia's confirmed technical specifications. The new model delivers 35% more compute capability than the previous generation version while processing 20% more parameters, all within a similar performance budget to the old model. In practical terms, the additional compute capability means the neural network can analyze more complex lighting relationships and make more accurate reconstruction decisions in the same amount of time. The increased parameter count means the model has greater capacity to learn and represent the subtle visual patterns that distinguish accurate ray-traced lighting from the artifacts and approximations that imperfect denoising produces. The fact that Nvidia achieved both of these improvements without a corresponding performance hit is a meaningful engineering achievement that reflects both the efficiency gains of the second-generation transformer architecture and optimization specific to the ray reconstruction task. The three specific areas where Nvidia is highlighting improvements in DLSS 4.5 Ray Reconstruction are the efficient denoiser model itself, deeper spatial awareness, and improved use of game engine data. The spatial awareness improvement addresses one of the most visible weaknesses of previous ray tracing denoisers, the tendency for the denoiser to make poor decisions about how lighting and reflections should behave at the edges of objects and in areas where multiple surface types meet. A spatially aware denoiser can understand the geometric and material context of the area it is reconstructing and make decisions that respect those boundaries rather than blurring across them inappropriately. DLSS 4.5 Ray Reconstruction's improved spatial processing means that the transitions between different material types in ray-traced scenes should look cleaner and more accurate, with reflections staying sharp at object edges. And indirect lighting respecting the boundaries of surfaces in ways that previous versions struggled with in complex scenes. The improved use of game engine pixel sampling and motion data is the third major enhancement in DLSS 4.5 Ray Reconstruction, and it addresses the temporal stability problem that has been one of the most noticeable weaknesses of ray tracing in games. When you move your camera quickly in a ray-traced game, the denoiser has to track which pixels correspond to the same real-world locations between frames and ensure that the reconstructed lighting information from previous frames is applied correctly to the current frame. When this temporal accumulation goes wrong, you get flickering, shimmering, and the visual noise that makes ray tracing look unstable during camera movement. DLSS 4.5 Ray Reconstruction's more intelligent use of motion data from the game engine means it can more accurately track the correspondence between frames during rapid motion, reducing the temporal instability that has historically made ray tracing look worse during the fast camera movements that gaming involves constantly. The launch lineup of 27 games that will support DLSS 4.5 Ray Reconstruction natively on Day 1 in August 2026 is one of the most impressive Day 1 ecosystems that any DLSS feature has launched with. The list includes some of the most visually demanding and most popular titles on PC, Cyberpunk 2077, which remains the gold standard benchmark for ray tracing visual quality in gaming, Alan Wake 2, which uses path tracing as its default rendering mode and represents one of the most ambitious real-time rendering pipelines in commercial gaming, Doom, The Dark Ages, ID Software's latest entry in the legendary franchise with a ray-traced lighting pipeline that shows what the technology can do in a fast-paced action game, Avatar, Frontiers of Pandora, F125, and Star Wars Outlaws among others. Having 27 games ready on Day 1 means that a significant portion of the PC gaming population will be able to experience DLSS 4.5 Ray Reconstruction in titles they already own and play, which is the kind of immediate practical relevance that drives real adoption rather than remaining a technology. Demonstration. The compatibility story for DLSS 4.5 Ray Reconstruction is one of the most important and most user-friendly aspects of Nvidia's announcement. Unlike some features that are restricted to only the latest generation hardware, DLSS 4.5 Ray Reconstruction will be available to all GeForce RTX graphics card owners through the Nvidia app. This means RTX 20 series, RTX 30 series, RTX 40 series, and RTX 50 series GPU owners can all access the feature when it launches in August. That is a massive installed base of potential users that spans every RTX GPU from the original Turing generation released in 2018 all the way through the current Blackwell generation. Nvidia's decision to extend DLSS 4.5 Ray Reconstruction to the entire RTX lineup reflects both the confidence they have in the technology's ability to run efficiently on older hardware and the strategic importance of maximizing adoption across their installed base, rather than restricting it to recent buyers. The Nvidia app override functionality that accompanies DLSS 4.5 Ray Reconstruction is worth specifically highlighting because it extends the feature's reach beyond the 27 games with native Day 1 support. Through the Nvidia app, users can enable DLSS 4.5 Ray Reconstruction as an override for any game that supports the older Ray Reconstruction model, even if the game developer has not specifically updated their title to use the new version. This override system means that the feature's effective compatibility is significantly broader than the official launch list of 27 games, covering any title that previously had Ray Reconstruction support of any version. Over time, as more developers add native DLSS 4.5 support and the override system covers more games, the proportion of the RTX gaming library that benefits from the improved denoising will grow substantially. The extension of DLSS 4.5 Ray Reconstruction. Beyond games to Blender, the widely used open-source 3D creation software, is a significant expansion of Nvidia's neural rendering technology into the professional creative tools space. Blender users who work with physically based rendering and ray-traced scenes have historically dealt with slow denoisers that cause the 3D viewport to take significant time to restabilize every time the camera position is changed or scene elements are modified. The creative workflow interruption that comes from waiting for the viewport to denoise after every adjustment is a genuine productivity problem for professional artists and hobbyists alike. Nvidia is bringing DLSS Ray Reconstruction to Blender in combination with their optics rendering technology, promising a much more interactive viewport experience with near-final quality image reconstruction that allows artists to see accurate representations of their lighting and materials without waiting for lengthy denoising passes. This is the kind of practical professional application that demonstrates the technology's value beyond gaming. The broader DLSS 4.5 ecosystem context that the Ray Reconstruction announcement completes is worth summarizing because it shows the scale of what Nvidia has built throughout 2026. DLSS 4.5 Super Resolution launched in January 2026 with the second-generation Transformer model, available across over 400 games. Dynamic multi-frame generation and the 6x multi-frame generation mode for RTX 50 series GPUs arrived in March 2026. The enhanced frame generation model improved the quality of AI-generated frames. And now DLSS 4.5 Ray Reconstruction completes the suite in August 2026. The total RTX ecosystem has crossed 1,000 supported games and applications as of the Computex announcement, which is a milestone that reflects years of developer relationship building and integration work across the PC gaming industry. The competitive context that DLSS 4.5 Ray Reconstruction exists within is one where AMD's FSR 4 and Intel's CSS are both improving their upscaling and reconstruction technologies as well. AMD's FSR 4 brought machine learning-based upscaling to RDNA 4 hardware and delivered meaningfully better image quality than earlier FSR versions. Intel's CSS has been expanding its game library and improving image quality with successive updates. But DLSS 4.5 Ray Reconstruction addresses a specific technical problem that neither FSR nor CSS has an equivalent solution for at the same level of sophistication. Ray tracing denoising is a distinct technical challenge from upscaling, and Nvidia's years of investment in the Ray Reconstruction technology has produced a capability that AMD and Intel have not yet matched with comparable dedicated neural denoising solutions. This specific advantage in ray-traced image quality remains one of the clearest differentiators for RTX hardware in the current GPU market. For RTX GPU owners of any generation who have been frustrated by the inconsistent or noisy appearance of ray tracing in their favorite games, August 2026 represents a genuinely meaningful moment. The combination of a more capable neural network model, improved spatial awareness, better motion data handling, and a broad launch ecosystem of 27 games including some of the most visually impressive titles available on PC creates conditions for ray tracing to finally deliver on more of its visual promise in real gaming scenarios. The version of ray tracing that arrives in August with DLSS 4.5 Ray Reconstruction is going to look better than anything that has come before it in this specific technology area, and the fact that it is arriving as a free update to every RTX GPU owner through the Nvidia app means the entire RTX installed base gets to benefit without needing to upgrade their hardware. Mark August 2026 on your calendar and update your Nvidia app when the notification arrives.